you can actually follow the same procedure when it is raised to m. Then it becomes minus m upon m plus 1, right, into a. It will be minus m into minus m minus 1 upon m raised to. For the third derivative, it will be minus m into minus m minus 1 into minus m minus 2 a cube upon m plus 3. And we generalized here, minus 1 cube will remain. It is m into m plus 1 into m plus 2 a cube upon m plus 3. And now how do we generalize? Minus 1 raised to n is fine. It will be, when it is 3, it is going up to m plus 2. So it will be m into m plus 1 etc. up to m plus n minus 1 into a raised to n divided by ax plus b raised to m plus n. Yeah. That would be nth derivative of ax plus b raised to minus m, or 1 upon ax plus b raised to m. Now the seventh, y is log of ax plus b. And just remember that we had formula as nth derivative of 1 upon ax plus b was minus 1 raised to n. Then what is the formula? N factorial a raised to n upon ax plus b raised to n plus 1. You will come to know why I have written this formula. Because when you just differentiate it once, differentiation of log of ax plus b becomes 1 upon ax plus b into a. Now can you tell me directly what is nth derivative of log? Because first derivative is this. So when we want nth derivative of log, it will be n minus 1th derivative of 1 upon ax plus b and 1 a extra. Okay, so we will say nth derivative of log of ax plus b is actually n minus 1th derivative of 1 upon ax plus b into a. Because this is, you will differentiate it further n minus 1 times. This is first derivative. And put n equal to n minus 1 into this, we get the formula as minus 1 raised to n minus 1, n minus 1 factorial, a raised to n minus 1 upon ax plus b raised to n into a. And it is better to remember it in this way only, because otherwise sometimes it is n minus 1 factorial, sometimes n factorial. A power is changing. In both the cases power of a is n, but other powers are 1 less. 8th, y equal to e raised to ax into sine of bx. Why sine of bx? Take it sine of bx plus c. Now what should we do? Derivative of e raised to ax into sine of bx plus c, one can very well determine. That's not a big job. A e raised to ax sine of bx plus c plus b e raised to ax cos of bx plus c. But then we need to generalize. Now what do we do? For cos n theta? Sine of bx plus c plus pi by 2. If we write, then what will you do with this a and b here? What is the use of y? We want a formula directly in terms of n. We are not proving anything. It is formula to be. I want this to be a single term. It's as simple as that. If we can manage that, good enough. E raised to ax stays. So the question remains about with a and b. What should I do with them? So I can always write it as e raised to ax into bracket a sine of bx plus c plus b cos of bx plus c. Multiply divided by under root a square plus b square. Instead, I am going for a substitution in the similar way. I am saying that let a is equal to r cos alpha and b is equal to r sin alpha. Therefore, a square plus b square is r square. That is what you are saying. And tan alpha is what? Tan inverse of b by a. When I make this substitution, it will appear as e raised to ax into bracket r cos alpha sine of bx plus c plus r sin alpha cos of bx plus c, which is nothing but r e raised to ax into sine of bx plus c plus alpha. So I got it again in terms of e raised to x into sine, where r is just a constant. Now if I differentiate it once again for the second derivative, d square of e raised to ax sine of bx plus c, I know that again this will get differentiated in the same manner. So e raised to ax will stay. Again I will get a sine of bx plus c plus alpha and b cos of bx plus c plus alpha. Again I will make the same substitution. Again it will become sine of bx plus c plus alpha. So it will become 2 alpha and 1 r will come common. This will become r square e raised to ax sine of bx plus c plus 2 alpha. And we can write nth derivative as r raised to n e raised to ax sine of bx plus c plus n alpha, where r is root of a square plus b square and alpha is tan inverse b by a. Right? Make a note. And all these 8, 9 formulae you will have to remember, because all the next problems will be based on that. The derivative will be nth derivative of e raised to ax sine of bx plus c will be r raised to n e raised to ax sine of bx plus c plus n alpha, where r is equal to root of a square plus b square and alpha equal to tan inverse b by a. So in reality the formula is nth derivative of e raised to ax into sine of bx plus c is a square plus b square bracket raised to n by 2 into sine of bx plus c plus n tan inverse b by a. Right? These are the only formulae we have for nth derivative. So whenever they give us a problem, find nth derivative, you will have to reduce that problem to any of the known form and then proceed. They can ask you to find, say, as the problem set is, find nth derivative. First problem is sine 2x cos 3x. Now what will you do here? There is no formula for sine into sine or sine into cos. Now you will have to use trigonometry. 2 cos sine, separate them and find nth derivative of each one of them. Of course, nth derivative, this formula is always valid, right? Nth derivative of u plus v is nothing but nth derivative of u plus nth derivative of v. So far as addition goes, there is no problem. So here you will have to use 2 cos sine. Normally the first angle is greater than second, right? Then the second one is cos raised to 4x. Again, cos raised to 4, you should write it as cos square square. Cos square is 1 plus cos 2x upon 2. Again square it, you will get cos square 2x. Again write it as 1 plus cos 4x upon 2. So you get only in multiple angles and then solve. Third one is cos x into cos 2x into cos 3x. Again 2 cos cos, multiply, again 2 cos cos, so there will be 4 terms and solve. Fourth, it is e raised to ax into sine of bx into cos of cx. Fifth, e raised to ax into cos square x into sin x. Sixth, e raised to 2x into sine of x by 2 into cos of x by 2 into cos 3x. Seventh, it is cos square x into sin cube x. And those who will complete this, they will have to think of sin raised to 5x into cos cube x. All are formula based. See it first. Those who can solve, they can start. I am just giving the hints. It is for the first one. It is 2 cos 3x sin 2x, and I am writing it as half. It will be 2 cos a sin b. Will be sin of a plus b minus sin of a minus b. Minus sin of a minus b. And so this will simply result in half into bracket sin of 5x minus sin of x, and then use formula for sin that we have, nth derivative of sin, that is plus n pi by 2, right? For the second problem, cos raised to 4x should be written as cos square square, that is 1 plus cos 2x upon 2 square, which becomes 1 plus 2 cos 2x plus cos square 2x upon 4, and again write it as 1 plus 2 cos 2x plus 1 plus cos 4x upon 2 upon 4. Simplify, separate and do it. For the third one, I will write it as half into 2 cos 3x cos 2x into cos x will become half cos of a plus b plus cos of a minus b. So cos of 5x plus cos x into cos x will be half cos 5x cos x plus half cos square x, which can be written as 1 by 4 cos 6x plus cos 4x, and this will be half into bracket 1 plus cos 2x upon 2. Hint for the fourth one, it is half into 2 sin bx cos cx will be half into bracket sin of b plus c into x plus sin of b minus c into x. Substitute and separate. Karo. So I have given hints till 4. Fifth mate is 1 plus cos 2x, again separate. This is 2 sin x by 2 cos x by 2 is sin x cos 3x, and 7th and 8th are a bit tricky. 8th is very tricky, 7th one can manage because we have formula for sin 3 alpha. Sin 3x is 3 sin x minus 4 sin cube. From that you can substitute sin cube. Cos square it is 1 plus cos 2x upon 2. So the answers, the very first one is half into 5 raised to n sin of 5x plus n pi by 2 minus sin of x plus n pi by 2. 1 raised to n is there. For the second one, 1 by 4, it's 0. Right? Then this will be half 2 raised to n into cos of 2x plus n pi by 2. Again this will be 1 by 8, so that will be 0, and it will be 1 by 8 4 raised to n cos of 4x plus n pi by 2. Here it will be 1 by 4 6 raised to n cos of 6x plus n pi by 2 plus 1 by 4 4 raised to n cos of 4x plus n pi by 2 plus 0 plus 1 by 4 2 raised to n cos of 2x plus n pi by 2. This will be half bx plus c raised to n sin of bx plus c into x. B plus c, sorry, one second. It is half sin of b plus c raised to n, half b plus c raised to n sin of b plus c into x plus n pi by 2 plus half b minus c raised to n into sin of b minus c into x plus n pi by 2. So there is nothing difficult from but here we have, or there was e raised to also. Okay, I will do the fourth one. I had given the hint for splitting, but I missed out that e raised to. So fourth one will be written as half e raised to x sin of b plus c into x plus half e raised to ax sin of b minus c into x. So the nth derivative d raised to n of y will be half, it is b plus c, it will be a square plus b plus c bracket square bracket raised to n by 2, that is r raised to n, but r in this case is this, right? It will be e raised to ax into sin of b plus c into x and plus it will be n tan inverse of b plus c upon a, right? Of course you will write it as n theta, but I had two r's over here, so you would have written it as, otherwise it can be simply written as 1/2 r1 raised to n e raised to ax sine of b plus c into x plus n theta 1 plus half r2 raised to n e raised to ax sine of b minus c into x plus n theta 2, where r1 is under root of a square plus b plus c square, r2 is under root of a square plus b minus c square, theta 1 is tan inverse of b plus c upon a, and theta 2 is tan inverse of b minus c upon a. Exactly the same way the next one will follow, and even the next one. But over here we don't have AB, so the values are there, you can determine R. Now the eighth one is important. For the eighth one, it is given as sine raised to 5x into cos cube x. Now here we will make use of De Moivre's in a different way. We will start with saying let z is equal to cos x plus I sin x. Fine. That is our z. So 1 upon z will be cos x minus I sin x, which gives me that z plus 1 upon z is 2 cos x and z minus 1 upon z is 2i sin x. How to make use of this? Because then we require cos cube, so I can raise both of these to power 3. So therefore I will get z plus 1 upon z bracket cube is equal to 2 cos x bracket cube, and z minus 1 upon z bracket raised to 5 is 2i sin x bracket raised to 5. Okay. Make a note till this, because now we are going to take product of these, and then we will get some simplified multiple angle formula. So it will be 2 cos x y sin x bracket raised to 5 into 2 cos x bracket cube will be z minus 1 upon z bracket raised to 5 into z plus 1 upon z bracket cube. So this becomes 2 raised to 8 I raised to 5 sin raised to 5x cos cube x. How do we simplify right hand side? Can we raise it to power 5? Right.
Z square plus minus 1 raised to 5 z square calculation.
Oh. Okay. Z minus 1 upon z bracket raised to 5 will be z raised to 5 minus 5 z raised to 4 1 upon z plus 10 z cube 1 upon z square minus 10 z square 1 upon z cube plus 5 z 1 upon z raised to 4 minus 1 upon z raised to 5. What happens is z raised to 5x, z raised to 5 minus 1 upon z raised to 5, that will be sin 5x, 2i. Similarly, this is cube and cube. Similarly, these two. Okay, so we should take advantage of this expansion. That's why we have taken it as z plus 1 upon z or z minus 1 upon z. Of course, this is a minus b, a plus b. One can very well go with the next step as z square minus 1 upon z square bracket cube into z minus 1 upon z bracket square. Is it okay? So we are reducing our task of getting 6 terms. So this will be expanded as z raised to 6 minus 3 z raised to 4 into 1 upon z square plus 3 z square into 1 upon z raised to 4 minus 1 upon z raised to 6 into z square minus 2 plus 1 upon z square. So we just simplify it and write it as z raised to 6 minus 3 by z square minus 3z square plus 3 upon z square minus 1 upon z raised to 6 multiplied by z square minus 2 plus 1 upon z square. So it becomes z raised to 8 minus 3z raised to 4 plus 3 minus 1 upon z raised to 4. I have multiplied by z square minus 2z raised to 6 plus 6z square minus 6 upon z square plus 2 upon z raised to 6 plus z raised to 4 minus 3 plus 3 upon z raised to 4 and minus 1 upon z raised to 8, which results in z raised to 8 minus 1 upon z raised to 8. So these two are gone. Then for z raised to 6 is again the same thing, minus 2 into bracket z raised to 6 minus 2 upon z raised to 6. Now for 4, what is the policy? We have z raised to 4 minus this कितना आता है वो? This and this is -2 and this is +2. So I can take -2 into bracket z raised to 4 upon 1 upon z raised to 4. And for z square we have these two terms only. So it will be plus 6 into bracket z square minus 1 upon z square, and 3 cancels, which is simply how much it will be? 2 raised to 8 I raised to 2 raised to 8 I raised to 8 sine of 8x minus why I am confused? Can you tell me? I am a bit confused, but why? 2 raised to 6 I raised to 6 sine of 6x minus this is 2 into minus 2 into 2 raised to 4 I raised to 4 sine raised to 4x. Sorry, that's why I got confused. This is simply 2i sine of 8x. Why 2 raised to? This is sine of cos 8x plus I sin 8x minus cos 8x plus I sin 8x. It cancels. It becomes just 2i sin 8x. I was confused because on the left hand side I already have I. It has to cancel from right hand side to get the answer. So it is 2i minus 2 into 2i sin 6x minus 2 into 2i sin 4x plus 6 into 2i sin 2x. And therefore I have 2 raised to 8i sin raised to 5x into cos cube x as two I can be taken common. It will be sin 8x minus 2 sin 6x minus 2 sin 4x plus 6 sin 2x. And then you apply the formula. So it will be 1 upon 2 raised to 7 will be there, I cancels. We have the given expression written as, therefore sin raised to 5x into cos cube x will be 1 upon 2 raised to 7 into bracket sin 8x minus 2 sin 6x minus 2 sin 4x plus 6 sin 2x, and its nth derivative will be 1 upon 2 raised to 7 into bracket 8 raised to n sin of 8x plus n pi by 2 and so on. But this is what in between goes. Okay. One minus two 6. 1 minus 2 6 बराबर, right? Make a note of this and we will stop here with maths. Is there any simpler way to expand this? Actually, we don't do all these things. We look at this and we directly write it as this power is 8. So 1 upon 2 raised to 8 into z minus 1 upon z bracket raised to 8 into z plus 1 upon z bracket raised to 5 into z plus 1 upon z bracket cube. So from here we directly come to this point. We don't do any of these things. If they go for something like sin raised to 11 cos raised to 7, so what will you do? You can't expand it like that. So we will miss all in between steps. It will be, if it is something like sin raised to 11x cos raised to 7x, then we will directly come to 1 upon 2 raised to 18 if you accept. Okay, it will be this sum. It will be z minus 1 upon z bracket raised to 11 into z plus 1 upon z bracket raised to 7 and start. This was for the first time we have explained everything. But otherwise, here in engineering we know that when you are writing it, you will simply say where z is cos x plus I sin x. That's it. Up to power 7, it will be the Pascal triangle that will help you. So you will expand it. That too we know that the powers are going to reduce by 1 or 2. When it is z plus 1 upon z, powers will reduce by 2. Okay. Normally it reduces by 1, here it is 2. When it is z square plus 1 upon z square, powers will reduce by 4. Z raised to 4, z square, 1 upon z square, z raised to 6. So everything can be written very mechanically. Right? Make a note. We'll continue tomorrow with maths. Tomorrow at the beginning I will ask everybody all these nth derivative formulae and then we start, because without that we can't work in this.